In this video, we're going to learn how to do implicit differentiation. We are going to solve the following examples. X squared plus y squared is equal to 9 and sin x minus x cubed y plus y is equal to 5x. So if you notice, these examples are not written as y equals, hence implicit. Ano nga ba pagkakaiba nito sa explicit? When we say explicit, our function is written as y equals. For example, y is equal to x raised to 4 plus 5x plus 10. So, our function is written explicitly. We have y on one side of the equation and the other side has the expressions in terms of x. And for this example, you can just do differentiation normally. So for this, applying the rules of differentiation, we have y prime is equal to, for this x raised to 4, we'll apply the power rule. It's 4x cubed. And then for 5x, the constant multiple rule plus 5. And of course, constant function for the 10, the derivative is just a 0. So, the derivative of this given function is 4x cubed plus 5. We will actually do the same for implicit differentiation in the sense that every term will be differentiated like what we did here. So, for y, we get its derivative with respect to x. For x raised to 4 also, derivative of x raised to 4 with respect to x plus derivative of 5x with respect to x plus the derivative of 10 with respect to x. So our derivative of y with respect to x is just dy dx, which is actually another notation for derivative. So y prime and dy dx mean the same. Okay, equals. So as you can see, this is in terms of x. So we can get, or we can just apply the rules of derivative to get its derivative with respect to x. So we have 4x cubed. Plus this 5x is also an x term. So we can differentiate it with respect to x. Apply the rule. So that's plus 5. And of course, derivative of a constant with respect to any variable will always be 0. So, still, we have the derivative dy dx is equal to 4x cubed plus 5. So, let's go to our examples for implicit differentiation. To do implicit differentiation, let us follow these two steps. Step 1, differentiate every term with respect to x. Step 2, isolate dy dx. And of course, another step, click subscribe to learn more from our future videos. So, ito na nga for our first example. Let's do step 1. Let us differentiate each term in this equation. So, we'll get the derivative of x squared with respect to x plus the derivative of y squared with respect to x is equal to the derivative of 9 with respect to x. Okay, for our first term, so this is an x term. We can differentiate it with respect to x. Just apply the rule. In this case, power rule. So we have 2x. And then plus, oh, look at this. This is a one term that we are differentiating in terms of x. So we cannot do that, right? So what are we going to do? So look at this very closely. So this one, derivative of y squared with respect to x equals, we can only differentiate y squared with respect to y, right? So how can we arrive at this derivative of y squared with respect to x? Only if we multiply this by derivative of y with respect to x. Because as you can see, if we apply multiplication here, we can cancel dy above and dy below. And we arrive at derivative of y squared with respect to x, which is this one. So, there. This is what we are going to apply here. So, we'll have the derivative of y squared with respect to y, but we multiply this by the derivative of y with respect to x. So, as you can see, it's like differentiating this term normally, applying the rules, but we'll get, or we have to annex or attach dy over dx. Okay, equals, so again, derivative of a constant with respect to any variable is a 0. So let us simplify this further. We have 2x plus, again in this case, we can now get the derivative of y squared with respect to y. Apply the rule, power rule. So plus 2y, and let us not forget the dy over dx equals 0. And let's do step 2 now. We are on isolating our dy dx. So let me just rewrite this. Ayan. So simple algebra, no? So we just need to transpose the 2x becomes negative 2x. And if we divide both sides by 2y, we'll get to the isolation of dy dx, because this gets cancelled here also. So we have our final answer for dy dx is equal to negative x over y. So that's it. So as you can see, our derivative also has a y in it. So yun lang ang tatandaan nyo. Normal differentiation, like x squared, so apply the rule 2x plus for y squared, apply the power rule, so 2y, but since it is a y term, you just have to annex dy dx. Okay, derivative of 9 is a 0. And go to the isolation of the dy dx, because this is the derivative that we are looking for. And for our second example, we have a trigoterm here. We have y's here. This is just an x term. And let us not ignore this part here. We have x cubed y, which is a product. So later on, we will apply the product rule. So let's have first a recap of the product rule. If you have a certain function, h of x is equal to the product of f of x and g of x, so its derivative is equal to the derivative of the first factor multiplied by the second factor plus the first factor multiplied by the derivative of the second factor. Okay, let's proceed. Let's do step number 1. So we will get the derivative of sine x over the dx minus the derivative of x cubed y with respect to x plus the derivative of y with respect to x. Later on, this is our goal, no? We isolate that. And then equals the derivative of 5x with respect to x. Okay, for the first term, derivative of sine x with respect to x is just a cosine x minus, so for this part, we will apply the product rule. So we consider this x cubed as our first factor, no? And y is our second factor. So we have derivative of x cubed with respect to x multiplied by the second factor y, then plus the first factor x cubed multiplied by the derivative of the second factor y with respect to x. Okay, we have the plus dy dx is equal to, this one we can do also, derivative of 5x with respect to x is just a 5. Okay, simplifying further, we have cosine x minus, let's do the inside first, derivative of x cubed with respect to x. So just apply the rule. That will be 3x squared. And then we have the y there. So 3x squared y. Plus x cubed. So this is just a dy dx, right? So dy dx. Then we have our plus dy dx is equal to 5. And let's not forget to, I always tell this to my students, if you have the minus, always follow it with grouping symbol, no? Because, you know, may pagka-tridor yung minus sign na yan eh. Okay, so we have cosine, oops, sorry, I forgot the x here. So we have cosine x minus 3x squared y minus, see, it becomes minus now, x cubed dy dx plus dy dx is equal to 5. Okay? So, there's step 1. We have differentiated each term in our equation. Let's now do step number 2, which is isolating our dy dx. As you can see, we have 2 dy dx here, no? So, what can we do to isolate? Because when we say isolate, there's only 1 dy dx on one side of the equation. Ayan. So, these two terms with dy dx should be together on one side of our equation. So, we have negative x cubed dy dx plus dy dx equals, so the rest of the terms are on the other side. We have a 5, and then we will transpose these two terms and become minus cosine x then plus 3x squared y. So that if they are together on one side, and this is common to these two terms, right? We can just factor it out. So we'll have dy dx, and then a negative x cubed dy dx by dy dx, it's just negative x cubed. And dy dx by dy dx is just a positive one. And equals, again, 5 minus cosine x plus 3x squared y. And we're almost there. We just need to divide both sides by negative x cubed plus 1 so that we can isolate our dy dx. So we cancel this and we only have dy dx, yay, equals 5 minus cosine x plus 3x squared y all over negative x cubed plus 1. And that's it. That's our final answer here. So learners, what would you like to learn next? Comment below.